Bonds are formed when two elements share electrons, but not all elements share electrons equally. Polar bonds are formed when two elements have different electronegativities. Electronegativity is a measure of an element's strength or pull on electron density in a bond. As an example, fluorine has the highest electronegativity of 4. It's going to pull electron density towards it. Meanwhile, the metals like lithium and sodium and potassium have a weaker pull on electron density when in a bond. That's why they're often found in ionic bonds. So let's give an example of ammonia, NH3. So if we draw our Lewis structure, as it's drawn, there are no formal charges here. But if we compare the electronegativities, we'll see that nitrogen has an electronegativity of 3, meanwhile hydrogen has an electronegativity of 2. This means for each of these bonds, we're going to be pulling electron density towards the nitrogen and away from the hydrogen atoms. What this will result in, if we redraw our Lewis structure, is that the nitrogen is going to be partially negative because it's pulling electron density away from the hydrogen atoms, which are going to be partially positive. Another example, methanol, CH3OH. Let's draw the Lewis structure. Carbon and hydrogen have electronegativities that are relatively similar, so these bonds aren't really going to be polar. But carbon and oxygen, for example, have a larger electronegativity difference. Oxygen will pull electron density towards it away from the carbon. Meanwhile, it will also pull electron density away from the hydrogen atom. So if we redraw this, our carbon will be partially positive as the electron density is drawn towards the oxygen, which will be partially negative. And this hydrogen over here will be partially positive. One more example, chloroform, CHCl3. Draw the Lewis structure. Again, carbon and hydrogen, that's going to be a nonpolar bond because their electronegativities are so similar. But if we compare carbon and chlorine, it's a larger electronegativity difference. The chlorine atoms are drawing electron density towards them and away from the carbon, which, when we redraw the structure, will result in a partial positive charge on the carbon and partial negative charges on each of the 3 chlorine atoms.